Okay, hello everyone. So this talk is about the question of how to interconnect two Openstack or more than two Openstack together. So in different situations, you have needs to interconnect two OpenStack deployments, two or more OpenStack deployments, in fact, or possibly multiple regions of one OpenStack. So between data centers or between NFV POPs, you may want such network interconnections with specific properties. One is to have them being available on demand. Of course, it's kind of an implicit need when we talk about cloud, but we will see why it's important here later on. Second, we need to have this interconnection in some cases to provide private addressing in isolation, which is something that you won't have if you use floating IP addresses. And last, we may want to have this kind of interconnections to be possible without the overhead of packet encryption, because, well, we know how to do this kind of interconnection with IPSec tunneling, but in some cases we don't need encryption, and IPSec is costly. So let's see how we can do this. So one option is to do this with an orchestrator, but introducing an orchestrator in the picture is not something that's always possible, and something that's not always wanted either. Indeed, there are contexts where there isn't a natural entity, a single organization in the picture, which would be the natural place for being in charge of deploying an orchestrator. So we don't know who would manage the orchestrator. There are organizational complexity involved in the introduction of an orchestrator in some contexts. The second aspect is, even if you have an orchestrator, well, to make these interconnection available on demand, you will need to have the orchestrator expose an API to users. Well, it's not impossible to do, but for some orchestrators, it's not what they typically do today, how they are typically deployed today. And last but not least, even when it's wanted or feasible, having an orchestrator in the picture is still extra complexity, which is most often better avoided. So even if you have an orchestrator in the picture, if you can deliver a feature without involving the orchestrator, it's usually a win. So how can we do this without an orchestrator is the next question. So what we propose to do is to deliver this kind of interconnections by extending Neutron's API. So as you probably know, Neutron is the networking component of Openstack, and it's actually a framework that's pretty much extensible with service plugins that you can introduce to add features and API extensions. So in this proposal, we have two pieces when we look at the API. The first piece that we need to mention is the user-facing piece. It would be a simple API allowing a project to define that a local router on one OpenStack is linked to a router on another OpenStack. And the intent, the idea, is that this API will be used by projects to define a same link symmetrically on both sides. So you will say on side A, I need to have this router being linked to side B router, the other router. And on side B, you will define the symmetrical link. And once this is done, the second piece enters the picture, second piece of the API, to allow Neutron-Neutron exchanges. So this API component will be here to allow a Neutron to check if on the other side you find a reverse link that matches the one defined on his side. And so in this example, after the first call, the little one bullet in the diagram, after the first call, the Neutron on the left side will check and, well, end up seeing that there is no symmetrical link on the other side. But after the second call, well, symmetricity exists, and the work can keep on. And, well, the same API is then used to retrieve the technical details, technical identifiers most often, which will be used to realize connectivity. So here, the parameters that will be used, that we will find in these exchanges will depend on the technique to be used, and I will talk about this more later. But at the end of the exchange, the key point here is that at the end of the exchange, each side has the necessary information to set up the interconnection. So we are talking about multi-tenancy and needs for network isolation. So this raises obvious trust and security questions, and there are two that I need to talk about. The first one is we need to trust that the interconnection will preserve isolation, of course. And here, with these ideas, it means that we don't want to have an interconnection set up unless this was explicitly asked by each project or tenant. And since we are involving multiple Openstack deployments, it means that we need to have this being verified on all of the sides. So in practice here, this is ensured by interconnecting if and only if both sides agree on what were the defined links. So the check that the links defined are symmetric. The last point related to this isolation, which is important to mention, is that as soon as you don't authenticate packets, well, we have an obvious requirement that each OpenStack instance has to trust the packets coming from the other OpenStack instances. So this means that this proposal is for organization and entities trusting one another and also trusting the network that will be used to carry interconnections. If you don't have this verified, then you need to use some other solution, possibly relying on packet encryption and authentication. The second point is that for Neutron-to-Neutron API exchanges to be possible, we need to authenticate them. So I need to explain this a little bit. So of course, each Neutron component on each side needs credentials to talk to the other side. Here, what is important to understand is that we don't need credentials to act as a project. We don't need credentials to act as admin either. We only need credentials for a specific user, at least for a specific role, allowing read-only access to the interconnection information. So to achieve this, keystone federation is not strictly needed for functionality, but we find that in practice, it will be necessary to use it to avoid having too much configuration overhead, to avoid having one set of credentials configured in a config file for each of the different OpenStack that you need to interconnect with one OpenStack. So I briefly mentioned that, well, technical identifiers are exchanged and that they depend on the technique used to realize the interconnection. So there are a few requirements for a technique to be applicable, like kind of obvious requirement that the technique can provide isolated network connectivity, whether it's L2 or L3 or possibly both. Another important, not requirement, but aspect is that we want interoperability here. Because if we have interoperability for the interconnection technique, it means that the solution will be applicable between two OpenStack that do not use the same SDN solution, SDN controller solution. So here are a few examples. We can use VLANs to realize interconnections, two switches face-to-face with VLAN in between. Whether it's appealing or not is another question. VXLAN gateways could be an option. The L2 gateway project in Neutron could be a possibility as well. And the last one I want to mention is BGP VPNs. It's actually one that we had in mind when preparing this proposal, and I will focus on it now. When you use BGP VPNs, so I won't do a full description of what BGP VPNs are. It's a routing technique used by telcos to realize isolated interconnections. Here in this case, the information that will be exchanged will be routing identifiers, which are called BGP route targets. And here, each side will provide to the other side the routing identifier that the other side will use to receive routes for a specific interconnection. And then connectivity can be realized in different ways, whether as an overlay over the one or with the collaboration of one BGP VPN routing. So here there are different options which both can have interesting aspects. So the benefits of this approach is that since each side independently allocates identifiers, you don't need to coordinate the use of a common address or identifier space. The other benefit is that this approach can be implemented today in Neutron by reusing the existing BGP VPN interconnection API. This interconnection service would already allow some level of functionality to provide interconnections, but today it doesn't have any API workflow to make this possible on demand. So by introducing this API and combining both, we end up with something that can work today with Neutron, with a service that has drivers, including for Neutron and including for many SDN controllers. And the last important point that makes BGP VPN an interesting option here is that BGP VPNs allow both IP and Ethernet interconnections. So let's wrap up. This proposal is meant to allow interconnection that will be on demand without the need to introduce an orchestrator in the picture, and a solution that will be light on the packet data plane without requiring IPSec in practice. So these interconnections will be possible to do between 2 Openstack instances or more. The technical aspects generalize easily to more than 1 Openstack instance, but only between trusting entities, as I explained. So this applies to inter-cloud context or inter-region, inter-DC, and it's also something that's very interesting in the context of NFV, where you have very often multiple points of presence for NFV platforms that are involved in the context of one telecom operator. And one point that I want to insist on is that this proposal also allows interconnections between Openstack instances that don't use that use a different SDN solution. So before concluding, just to give you an idea of where we are in the context of the work on this proposal. So we are working on redacting Neutron specs for letting the community review and discuss the proposal. And we have also an implementation that we can propose based on a POC that was done at Orange in the past months. So this implementation, as you may have guessed, implements the BGP VPN technique that I just explained by simply reusing, in a service composition kind of way, simply reusing the existing Neutron BGP VPN interconnection service. That's it. Maybe there's some time for questions. I don't know if you do questions during lightning talks. Say no. Okay, thank you for listening.